Diode quantity 1. Okay, well, I would not think I ordered only one diode. Oh, but I ordered one pack of, they look like 5mm clear. So our coin cell LED tester confirms these are violet. A nice change from the standard red, green, blue, yellow, amber, orangey kind of stuff. Violet. Very bright. Woo! This could probably make a good flashlight, actually. 30 pieces of F5 5mm pink round super bright LED lamp WZ. And yes, they are bright. From Orchid for 99 cents US. These took 3 weeks to get here. So another seller I might tend to order from when I need things in a hurry. And there's really no other info provided. It's 30 bright pink LEDs. Something different for a change. This is called finding. I don't know what they're hoping to find, but I'm hoping to find something I can put to use. So finding is what? This is finding. It looks like a very small probe tip and 3 wires. Let's go find out what I found. 1 meter black waterproof digital thermal probe or temperature sensor DS18B20 from A, Cumming 868. I won this as an auction bid for $1.02. It is a probe temperature sensor based on the DS18B20 chip. It has a stainless steel tube. It's waterproof, moisture-proof, rust-proof. Stainless steel, 6 by 50 millimeters. So 6mm diameter, 50 millimeters long, I suppose. You can power it from 3 to 5.5 volts. Operating temperature minus 55 Celsius to plus 125 Celsius. Well, that should be within the range of what I would use it for. And in the more likely range I would use it, minus 10 to plus 85, it's got an accuracy of ½ degree. Although if I want to boil water with this, I'd be looking for 100 degrees. So what's the accuracy at that point? It's got 3 wires, power, ground, and data. 100 centimeter long cable, and they threw the word Arduino in there to help sell it. So not only did I get it a couple of cents cheaper on auction, it only took 3 weeks to get here. Do these guys sell anything else? I don't recognize the seller name. Oh dear. Let's just back out of here quietly and quickly. So they may have a couple of things of interest to me, but they do have 25,000 things for sale, and they're not all like this, so we'll see. Well, Maxim has a datasheet for this one-wire digital thermometer chip, provides 9 to 12-bit Celsius temperature measurements, has an alarm function, and non-volatile user programmable upper and lower trigger points. So I guess you can set this up to alert you if a temperature goes in or out of a certain range. That way you don't have to necessarily poll it. You can just configure it and let it tell you when something's going on. And you can derive power from the data line by parasitically taking power. Each of these devices have a unique 64-bit serial code, kind of like their own address, so you can throw a bunch of these on the same one-wire bus. So that makes it easy to have a bunch of these monitoring different things all at once, and then just one wire and ground to read it. Standby current is at most 1 microamp, and when you're active, you might draw up to 1.5 milliamps. So yeah, that sounds GPIO friendly for deriving power off of the data line. If you're going to use that built-in E² PROM, you get 50,000 writes. That's pretty good. And data retention is 10 years. If you're going to use that parasite power mode and steal power from the data pin, you must ground VDD. The bidirectional data pin is open drain, so it's going to need a pull-up, it looks like. And yes, here's a block diagram showing an external 4.7K pull-up on data. They're saying to assure that it has sufficient supply current, it's necessary to provide a strong pull-up on the bus whenever temperature conversions are taking place or data is copied from Scratchpad to E2 Prom, which, of course, these are the high current drawing modes of operation. This can be accomplished using a MOSFET to pull the bus directly to the rail. And then there's all these things to think about when doing this. So it kind of starts to sound a bit like more trouble than it's worth if we're just playing around with this. Give it our own supply. This says 3 times APDC 5C32. What does that mean? It feels kind of big, so let's find out what's hiding in here. Probes! And it looks like I got 3 different sets of banana plugs to alligator clips. Tons of uses for that. Alligator clip test leads to banana plug probe cable 1 meter battery clamps. $1.29 from Good Module. So very straightforward. They are 1 meter long. They have banana plugs and they have alligator clips, so you can plug these into a bench power supply with the banana plugs or into even maybe a multimeter, and you can clip on to things. Sometimes what I find I'm doing is I might have meter probes in the meter or something else plugged into the power supply, and then I need alligator clips on the other end to clip onto something. So I end up taking an extra pair of alligator clips and clipping it onto the end of the probe or whatever, and then going over to wherever the circuit is. So this way I can just go direct and minimize all the losses from any interconnects like this. It's better to have as few junctions as possible sometimes. And well, that does look flat flex cable-ish. A whole bunch of different width flat flex cables to go into different connectors, and a whole bunch of flat flex connectors. 10 pieces flat flex cable connector pitch 0.5 to 1 millimeter, available in 4 pins to 40 pins, available with top or bottom clamshell contacts. So, to make a long story short, I went with 1 millimeter pitch, and I got 3 different connectors. I got 16, 24, and 32 pin, but I can't remember if I got top or bottom contact versions. Let's just go with something, because I think the price was the same for bottom or top. So the 16 pin, US $257 from Superior Buy 2014, and you get 10 for that price. 24 pin 10 pieces would be $2.82 US, and 32 pin 10 pieces are $3.11. So it's these guys with the surface mount pins, and I've got a whole bunch of breakout boards, so one day I will just put a bunch of these connectors as needed on these breakout boards and give me 0.1 inch headers, and then I stuff in whatever flat flex cables I have that go into these appropriate pitch and pin count connectors. One thing I do have is that e-ink screen, and it has, I believe, a 24 pin flat flex cable. I think it's a 0.5 millimeter pitch. So that's the kind of reason I'm collecting up a whole bunch of things like this. And I might have a couple of project ideas soon. So that's why I'm ordering different pin counts and different pitches to be well prepared. So with these 3 particular connector sizes, I also ordered the matching pin count of cables. So 16, 24, and 32. The 16 pin 10 centimeter long 10 pieces are $2.11 US from Superior Buy 2014. 24 pin 10 centimeter 10 pieces $2.49. 32 pin 10 centimeters long 10 pieces $2.79. I got them in what they're calling forward direction, so that means the contacts are on the same side of the cable and they've insulated the other side. Reverse direction means one end of the cable has the contacts facing up, the other end has the contacts facing down. So depending what you're doing and if you need to bend something across a certain way, it makes more sense to have the contacts open on one end or the other. What's a mailbag without an expansion board module? Okay, here we go. What's in here? It has to be something good, but oh, it's wrapped up tight. Aye. Arr. Oh, okay, what is that? Okay, look at that. That looks like an infrared transmitter and receiver, right? With 3 pins on it. That's pretty straightforward looking to me, so let's set that aside. It came with what? A bag of stuff. Oh, is that a kit? Look, it's a blank circuit board with a bunch of parts in a bag. That's a kit. Okay, what is it? There's no instructions. Is this a 4017 with a 555 and a bunch of LEDs? I mean, come on, what could it be? Okay, that looks like 4B17 or 4817, but I'm going to call that 4017. And NE555. That looks like 10 LED light chaser based on 555 clock and 4017 decade counter. 1 LED on at a time. NE555 CD 4017. I don't know why they say LCD. Light Water Sweet Do-It-Yourself Kit ICSK057A must be a kit part number. Red LEDs. Basically looks like a 4017 10 LED sequential light chaser clocked from a 555. And it's the surface mount version of the kit. It has a potentiometer as well to control the clock rate, presumably. So I just thought this would be nice to try to see, can I do surface mount soldering still? It's been a while. So 99 cents US from DIY Box. I ordered this stuff a long time ago, so I'm not sure how long it took. It's probably been sitting here forever. Now I also ordered at the same time from DIY Box 1 infrared sensor obstacle avoidance module probe for smart car robot. In other words, an IR transmitter and receiver with Arduino friendly hookup, onboard resistors, everything you need. But the listing is no longer there. I only ordered 1, not 2, and the price was about half of this, 99 cents US for 2. This happens to be from World Chips. I'm just showing it as a reference point. But I bought this way back. They don't say much about it. It's very small, 1.5 centimeters square. Just has what you need on it. So, yeah, I'd like to try this out and see if I can actually detect obstacles in front of it, and if so, surely that can have a lot of uses. I look forward to working with all this stuff, as usual. Stick around, find out what we can make happen with all of this.